Why test data can be a killer for CI/CD. So first, let's see what is CI/CD. Actually, I haven't seen CI/CD so much in practice. Everybody talks about it. But the idea is that after some initial approval, which is usually the pull request or for some teams even the commit, there is no other manual task involved and things get to production automatically. So this is the first thing which is surprising because usually managers, they want some change advisory boards and some additional testing and approvals, and this should not be the case. And second thing is that it should be very fast and very frequent. Because why developers like CI/CD is because they can get the code to production very quickly, they get the feedback very quickly, and they can have the clear mind, they can focus on other things. And that's the problem, like we think everything works, we develop, maybe now with AI also automatically, then we validate, which is basically we test the code or we qualify it using other methods. And then this can also be automated, and then we deploy it, which can also be automated. So is there any problem? And actually there is. So what's the problem? The thing is that if you want to test something and be sure that those tests are going to guarantee that I can deploy to production, there will be a certain number of tests which can be huge for some complex applications. And so in a context of, for example, a bank, I will have tests that focus on registering a new customer, a test that will create a subscription, a test that will issue an invoice, that will collect payments, and that will maybe create a dispute. So usually what happens is that those tests will be chained one after the other because you can't create a dispute without having a customer and without having a payment and without having before that any subscription. So what usually testers do manually and what is replicated in automated tests is that you chain the test and then they take some time. So if you do end-to-end testing, this is going to take maybe 10 minutes, maybe 1 hour. If you have a huge product, you can imagine for example, Office 365, something like that. It's going to take a long time. And that's the issue. So the idea is that we could run the tests in parallel. So instead of doing everything as a chain, we could, at the same time, create a new customer, but at the same time have a customer already created and try to do subscription. Already have a customer that has a subscription and try to issue a payment, etc. So the idea is to gain time in CI/CD. We need to run tests in parallel, but without having an initial state for those tests, we can't proceed. And that's basically the idea of why we need test data. What is test data for testers when they define automated tests? We need somehow to provision test data in the environment so that we don't start from scratch for every test because that would take too much time. And the CI/CD usually, there's no more any issue with automating deployment. There's no more issue about automating tests. Today, everything can be coded. The real bottleneck is how to ensure that I can run all those tests in parallel. So my name is Václav Brož. I have been focusing on test automation and test data automation for the last 15 years. I'm founder of Pump It Up and Sixpack, and I'm also leading a QA Kitchen QA community. If you want to challenge me, you can do it also during the talk. And those that are online, feel free to have questions. I will try to check them regularly. And I like to be challenged, so really go ahead. So back to our problem of the end-to-end test and how to provision test data for the end-to-end test. So as I said, I like to challenge myself. So I have a few challenges here that are usually set by people. So first challenge is like, why do we need end-to-end tests? Maybe we don't need them anymore because microservices are designed to be self-sufficient. We could just test those microservices, right? So this is the idea of unit testing, system testing, and also contract testing. In practice, it's a nice idea that doesn't actually work because you can test microservices in isolation, but the core functionality usually is in the orchestration between the microservices. So, for instance, you have all seen those videos that are called on YouTube integration unit test pass, but no integration tests. So this is a typical example of very heavy functionality in each component, but together it will not work. And actually that's the paradox, which you can verify it in your enterprise. I'm sure that product owners will not rely on unit tests to release a product in production. So my stake is that end-to-end tests are still required, even if you don't have a large number of end-to-end tests. Without them, probably you will not approve to have automated deployment to production without any manual validation. Second idea out of the box to challenge all that is that we could create ephemeral environments and run the tests on the ephemeral environment, which is basically a very good idea. For example, many teams use Docker Compose or similar ways how to provision a test environment for each pull request. Then after each pull request, you can run all the tests on ephemeral environments. And there the test data issue disappears because for each environment, you can provision a very deterministic setup of all data, and then you can start all tests in parallel. The issue is that, so basically this diagram shows how the ephemeral environments could work. You can provision test environments in upfront, like it can be a virtual machine, it can be in a Kubernetes namespace, it can be whatever you want. And once you have the test environments, you can also add data in there. This is calling seed data. You can have some kind of template of an environment with data, and then you can run any test very quickly on it, and then you can recycle the environment after it. So it costs some money, but it looks like promising. The issue is that for achieving that, you need that all teams in your landscape have full automation. And this starts to break when you introduce ERP systems like SAP, if you introduce like heavy billing systems and things like that cost some money. And also it breaks when you introduce software as a service, because maybe you are not able to provision an instance of the software as a service for each environment very quickly. It's a nice idea. As long as you're a small company, as a startup, it can work. And as you grow, this becomes unbearable. And actually, all legacy big enterprises like banks, telcos, etc., it's simply not achievable. And the third challenge, like how to achieve parallel testing, how to prepare test data for parallel tests, is let's copy production, right? And this is the legacy approach. We take the production database, we put it in the test environment, we run some masking and things like that because of GDPR, but also because we want to protect our data. And then we're done. We can run tests because we have data there already, and they are very rich in shape. So the only thing we need to do is ensure this anonymization is right, and ensure that maybe we have refreshes of those data over time. So there are many very advanced services that allow you, for example, to do virtual data. So they continuously copy data from production to test environments with anonymization. So you can then provision test data very easily. So I call that magic here. You take the production and you put data in the stage environment, and this is the magic. Now the question is, what happens if you have production that is made of microservices and stage that is made of microservices? Like now suddenly you don't have any more like one magic script. You have hundreds of magic scripts that you need to maintain somehow coherently. So then, for example, if you want to replicate a stage environment and you have 100 of microservices, each has a different persistence layer. Some don't even have a transparent persistence layer. I mean, you don't even access the persistence layer. So how do you do that? So we have several hard truths here. 2 of them basically. So we need enough rich test data for allowing to test in parallel any product before going to production. And copying data from production is very difficult to achieve when you have microservice architecture. And then we have a soft truth, which could be somehow challenged. In some environments it works, but usually it doesn't. And this is that we could have an ephemeral environment. Even stage could be an ephemeral environment. So in bigger enterprises, this is not achievable, and you need long-lived environments that you care about, and you manage the test data. So this is the problem, like how to have on-demand test data, how to provision them for each test separately. And it's not synthetic data, because synthetic data, usually people imagine that it's like something like fake. We need data that are coherent across all microservices. So the basic idea is very simple. We have a tester, or let's say automated test. Before starting, it requests some data. It gets them hopefully immediately, and then it can proceed and test with those data. So those data, you can imagine, it's, for example, a customer. So in a banking environment, you will have a bank client, and you have the request that is not only I need a client, you will have more specific parameters. I want a client that has a specific subscription, that has a specific account, card, and things like that. And this can differ per test. So you will have a vector of parameters as input, and you want as output test data that are pre-created in your stage environment. So if you imagine a stage environment that is made of many systems, many middleware, like Kafka or any other messaging system, it's about having test data created everywhere in a coherent way. So you can't just create the data in a banking system just in core banking without having it in CRM, because otherwise, if you are going to test some activation of a new service, it's not going to work. You are not able to proceed. So you need to somehow achieve that it's done everywhere. And the only way how to do it with microservices, where you don't control the persistence separately, is to replicate the business process. So first you create the data, for example, in CRM. Then you order some services. Then you activate the digital portal. Then you validate your customer that it has some credit. You can have a card, and it can proceed to some payment. And this is replicating the business process. What is nice about this is that if you replicate the business process, you are sure you are going to achieve a coherent state, so some referential integrity of the test data. The problem with that is how to achieve it, because you have many teams to coordinate. So the idea is not something completely new. Is instead of inserting data in the databases, instead of inserting data in various messaging systems, etc., which is actually not achievable, you ask teams to define APIs that are specifically for testability, for inserting test data. So instead of you doing it yourself, you ask your teams to not only develop the application, but also to develop some API that will allow you to provision test data. So then the applications, here we have 2 domains, 2 teams. Instead of having only APIs that allow the applications to communicate between themselves, there's a new API that allows to provision test data. And this, why is it interesting to have a specific API? Is because you might need a little bit more complex provisioning than just like what you would do in production. Typically, sometimes you need to create data in the past. So this you will not allow to do that in production, but in the test environment, you need that. Or you need to provision a product that is no more active in production. So those are arguments why it makes sense to define APIs that will be specific for the test environments. And you are not able to do it yourself. You need to outsource it to the teams, to the domain owners, because otherwise it's too complex. Then there's a second core idea that I'm bringing in, and this is to decouple the lifecycle of the test data from actually the usage of the test data. So instead of relying on the API to be live at all times, you would introduce some kind of middleware that would decouple that. And you can do it in advance. So let's say during the night, you call all your small APIs to create the test customers, etc. You store them in a buffer. And once you want to do some regression testing, you just request those data and they are ready. So this is how it can look like. Here I call it test data gateway. But it's basically some portal or some buffer, whatever. And the idea is that you continuously try to create test data for the future. And once you need it, they are ready, and you don't need to wait. Because in asynchronous systems, even if you do it automatically, it can still take minutes to hours to replicate the data across systems. So you don't have only this upfront provisioning, which is one of the benefits. You also have the discovery, which can become a benefit. Because if you have an environment with hundreds of microservices, maybe you will have tens of APIs to provision test data. And then it makes sense to have some kind of system how to discover them so that you don't have to maintain it manually. You also need some retries because maybe the test environment is broken suddenly because some team is releasing a new version. So in case another team requests data, you need some retries. And of course, observability, I think this conference is full of observability tools, but even for test data, it makes sense to have observability and to discover when it's broken. And third idea is composition, because as I discussed earlier, the test customer is not just a test customer, it needs to have a product, you need a payment, etc. So the idea is that instead of calling only one API, you need to call several of them and compose more complex test data that you will be able to use in, let's say, edge cases. So for example, if you want to test the activation of a card, you already need an activated card, but you can't have a card without a customer. So you need to call 5, 6 APIs to get the customer with the card, and your test is only about the activation. So this is called composition. It looks a little bit complex, but we can apply a pattern to that, which is called orchestration pattern, which is basically you need to have some kind of end-to-end team, or it can be one of the teams that you have in your landscape, and that team is responsible to call sequentially the other API. So then you can kind of build a tree of APIs, and you can compose more complex data by calling more simple data. So the final architecture that comes out of that is that basically you have developers, agile teams that maintain applications, but at the same time, they maintain those, let's say, APIs for test data creation. Plus, you might need some end-to-end teams that will do this orchestration, which usually is not a lot of things, not a lot of test data, but it still requires some team to handle that. Then you might have this gateway. Here I call it test data portal. And this gateway exposes a catalog of test data to the users, which can be manual testers or automated tests. And you have continuous refilling of the test data stock, but not only refilling, but also the full life cycle, because maybe after you have tested your test script, maybe you want to delete the data from the environment because you don't want just to add all the time, you also need to delete. Right, so what are the benefits? Again, the goal is to have smooth CI/CD, which in minutes allows you to test the whole solution or whole product. And here, you can get the data instantly, even in very complex shape. Each scenario can have a different data set, and therefore you are able to run all the scenarios in parallel, which is not, of course, it will cost you money, but you will need to have a lot of CPU, etc., to run all those tests. But the time is key in CI/CD. And there's not only this, but for example, if for creating test customers, you need some AML portal that is not available very often, this pattern allows you to be resilient to those changes. So you don't have all systems up all the time, and still you can proceed with your tests. Also, what is interesting is that you don't have to implement this pattern like in your whole company at the same time. It's just an architecture pattern that you can progressively implement, and you can see how it evolves, whether you need to assign specific team to handle it, or whether you are able to decentralize. Cleanup, I've said that cleanup is important, and of course, since microservices are done for scalability by decentralizing, this basically replicates this decentralization pattern 100%. So the key takeaways and the core ideas is that in microservices, you don't have anymore some kind of architecture team or central team that owns the whole data set. This is no more achievable because it's too complex. And to tackle it, you have to admit that copying production is no more feasible. So, to be able to test quickly, you need to elevate the data to be part of the architecture of the applications. So instead of just maintaining applications, maintaining this observability of the applications, and maintaining automated tests, the team should also maintain test data APIs that allow other teams to consume the data. Right. Thank you very much. And I see that there are no questions online, so hopefully there will be somebody challenging me here. Please. Yeah, go ahead.
I just wanted to ask about the life cycle. So different people implement CI pipelines differently. In this model, are you suggesting on every push we run all this testing cycle? And also, we were trying to implement such a system, but we didn't know when we implement full test coverage and when we implement targeted test coverage.
Okay, so there are two questions that I will repeat for online people. What is the life cycle about? Whether we do release on every push, etc. So I don't think it needs to be on every push. In different environments, the CI/CD lifecycle can differ a little bit. There are trunk-based development teams that on every commit on the trunk will run the CI/CD pipeline. There are other teams that will still have pull requests, which probably is something that I would personally recommend because the pull requests can hold all your auditability and things like that. And there are other teams that can still do, let's say, micro-releases, still create release branches from the trunk branch, and therefore they can, for example, have 2-3 releases per day. So I don't think it's necessary to have the life cycle that every commit will trigger a release, but still in a complex product, the idea is that you should have a release every day. You should not carry on the context overnight, because when you code something, you want to be sure that it works, and that next day you can focus on something new. So the idea is that in CI/CD you still have a very frequent deployment to production, and that's the main benefit of how to proceed. The issue is that you still need to test it, so this is why we have all those problems. And the second question was partial coverage or full coverage. So this can be optimized, of course. So you can. If you are sure that your architecture is, let's say, very, very wide, you have a lot of systems and a lot of domains, maybe you are able to based on which system you touch, to derivate which systems could be impacted and which end-to-end scenarios could be impacted. So then, of course, you don't have to test all test cases. But in practice, in microservice architecture, usually by touching just one system, usually there are many test scenarios to still run, even if you limit them. And therefore, I think without parallelization, you will not be able to achieve full CI/CD. You will very fast go back to release management, where you will need several days to validate that your change can be deployed. And when it's several days, you will start to have release managers, you will start to have manual testers that will start to say it's cheaper to test it manually, and you will digress back to release management, which is, I'm not saying it's bad, but it contradicts the benefits of CI/CD. Very well. Online, no questions. I don't even see how many people are online. So if the... Yes. This one or before? Yes. I think all the slides will be available for all of you in the recorded session, and also, I don't know, I think also as slide materials automatically. Thank you, guys. So I give you back 15 minutes.